Alright, today we're going to talk about how we can get something to rotate. So up here I've got a picture of a wrench and a bolt. And I want this wrench to rotate around its axis of rotation, the point right there. Okay? So how can I get that to happen? Well, I know linearly if I apply a force to something, I can make it accelerate. Okay? Here, it's similar but not the same. Okay? If I would apply a force right here at point A straight down on top of it, it's not going to rotate, okay? It's just going to set right there. If I apply a force right here at point B, straight down, it might rotate if I apply enough force, okay? And same with right here at point C, okay? However, what you may notice from personal experience is that as you get further away from the point of rotation, which we often call this our lever arm, and we denote it with the letter D in this class for distance. But you'll notice that as you get further away, the force required to rotate this is going to become less and less, okay? Before, if we wanted something to accelerate, we'd apply a force. The bigger force you applied, the greater the acceleration. In this case, that might not necessarily be true. I could apply a really big force here at point B. It might not do much. Whereas if I'm further away, I could apply a smaller force and it's going to rotate. Okay, so it's not dependent upon just the force. It's dependent upon the force and the distance away at which you apply that force. And it's also going to be dependent upon the angle that you apply the force as well. If I apply a force here at point C going this way, okay, it's not going to rotate at all either. All right, and we call this torque. We use the Greek letter tau to represent torque. So let's go ahead and look at some notes for this. Okay, torques cause something to have an angular acceleration. Okay, so they cause something to rotate. All right, they cause a twist or a turn. You apply a torque, you can make something speed up or slow down angularly, rotate faster or slower. It is a vector because you can make something rotate counterclockwise or clockwise. Okay, and just like before, counterclockwise is our positive direction, clockwise is our negative direction. The units, okay, well, it's a Newton times a meter, okay? Reason being, okay, the equation is tau, all right, it's another Greek letter because we're still dealing with rotation, is equal to the force that is applied multiplied by the distance that is applied away, the lever arm, multiplied by the sine of theta. We kind of left that part out earlier. Didn't mention it a whole lot, but there's an angle component to this. So let's go ahead and go back and look at our picture here. Again, if I apply a force in this direction, I'm not going to rotate the wrench. I have to apply it perpendicular, okay, to my object here. All right, so what angle are we going to use? Well, whenever you want the angle for the problem, what you do is you start at your axis of rotation. Okay, so I'm going to start here at the axis of rotation. Then you're going to draw a line down the lever arm until you get to where the force is being applied. And then you're going to draw in the direction that the force is applied. So right here, if it's applying it straight down, I go like that. Okay, so I'm using this first example here. All right, so again, start at the axis of rotation, go down the lever arm to where the force is being applied, draw the arrow in the direction the force is being applied. This angle right here is the angle for our equation. So let's look at that equation again. It is equal to the force times the lever arm times the sine of that angle. Okay, so when is this going to be the biggest number? Well, we know that the sine of an angle is going to be anywhere between -1 and 1. Okay, and from our math classes, we should know that when we have the sine of 90, that is going to get us 1, which is the biggest number we could possibly have. Okay, so when a problem says that it needs to apply the maximum torque, okay, for the minimum amount of force, we know that our angle needs to be 90. Okay, if you want to get the maximum torque for a force, then you need to go at a 90-degree angle. If you want to apply the minimum amount of force to be able to do this, you don't want to have to push very hard, okay? You want to have an angle of 90. All right?